Hello everyone, let's discuss question number 28. The question states, if 5 times bracket starts tan square x minus cos square x is equal to 2 cos square x plus 9, then we have to find the value of cos 4x. Okay, so we write the equation here and we replace. If you remember, we had a property that tan square x minus sec square x is equal to 1, right? No, the property was sec square x minus tan square x equal to 1. So when we replace tan square x by sec square x minus 1 in this equation and rearrange the whole equation, it results in this. Okay, now we assume cos x square to be t. Now putting t in place of cos square x, we know that cos x is equal to 1 by sec x, or we can say sec x is equal to 1 by cos x. So when we replace cos square x here, we'll replace it by 5 by t. That is, we'll write t in division. Okay, we write t in division. Next, now we'll take t and cross multiply it on the other right hand side, and it would give us a quadratic equation in t. 9t square plus 12t minus 5 equal to 0. Now by normal, as we solve a quadratic equation, we would get two values to this t, that is t equal to 1 by 3 and t equal to minus 5 by 3. We would not consider the value t equal to minus 5 by 3 because we know that cos x is lies in the element in the range minus 1 to 1, and cos square x lies in the range 0 to 1. Accepted? Hence the only value possible is 1 by 3. Now cos square x is equal to 1 by 3 and we need to find cos 4x. If we remember, there was a property for cos 2x, that is cos 2x is equal to 2 cos square x minus 1. We will use this property successively 2 times to find the value of cos 4x. The first time, cos square x 1 by 3, we put it in this equation and find the value of cos 2x, that is minus 1 by 3. Now we'll use this cos 2x value and put it in the next equation successively and find the value of cos 4x, that is minus 7 by 9. Hence the correct option is option 3.